All right, I've pulled the trigger. We're live.
Right.
Hi, everyone. Hi, everyone. Welcome to Undersampled Radio, episode 23. We've almost reached a quarter century or whatever. We are going to have an awesome show for you today because we've been off for weeks and weeks, it seems like. We've been busy, hard at work, changing our setup here. Once again, I have changed my recording situation, hardware and software-wise. So 95% chance my computer will blow up during this. And if that happens, Matt, just send the rescue teams in, okay? There's some awesome news we have here in the show notes today. There's a machine learning conference. Now, I'm not actually, so we're on episode 23. Matt, can you recall an episode when we didn't mention machine learning? Has there been one? No, okay. It's cool stuff. I want to go to this conference. You going?
Well, I was going to ask David, who we'll introduce properly later. David Holmes from EMC is waiting quietly in the wings, and I thought maybe he might have even been to this conference last year because apparently this is the second one.
I didn't go to the conference last year, and I just found out about it 2 minutes ago when I opened up the show notes. They appear to have the usual bunch of suspects turning up to talk at it. So I think the interesting thing about these events is it's going to follow the same old format, right? There are going to be a bunch of smart people who are going to stand up and they're going to do a keynote presentation and they're going to give you your perspective on the world. They're probably going to explain how companies like Airbnb, Uber, and Netflix are completely digitalization and transforming the world. And they're going to try and draw some tenuous analogy between what we do in the energy industry and what a company that manages a lot of cars and the sat-nav system does. And actually my experience of these events is that, you know, some of the keynotes have a few interesting points. They can usually be distilled into about 60 seconds, but where it really all happens is when the formal presentations stop and people actually start talking to each other, or where you get small breakout rooms where people sit down and talk about the things they've done. Because I'm with you, I think this is an area that is going to be very transformative over the next few years. We're doing a bunch of research projects, which I'll perhaps touch on later on, that look at ways you can use machine learning in our industry that certainly I didn't expect. So am I super excited about going to this event? I'm not sure, but it's bound to be interesting.
Yeah, I feel like these sort of events, because it seems to be organized by a sort of commercial conference organizing company, right? So that presumably they just sort of, I imagine them just having this sort of giant board of sort of opportunities, like buzzwords that they're probably just looking at, like Google search for frequency.
They probably have some machine learning system that comes up with the conference title.
Exactly. Like, and you know, versus dollars basically, and we can get people to come to this conference. You know, so not you know, so it's sort of, so I almost just don't like the premise of organizing the conference. It's like, let's make money, but fair enough. Like you say, I think some good conversations and you know, meetups and things have come out of it. And as you know, you look at the list of people who were there last year, because I don't think they've got any talks lined up yet for 2017. In 2016, it's sort of, you know, people from Baker Hughes and Schlumberger and CGG and and Chevron and operators as well. So yeah, I mean, you know, on the one hand, it's like they're clearly just, they invite these people so that they can sell more tickets to their conference and make it a big success. So yeah, I don't know. I guess I almost feel like their whole sort of the way that they operate is essentially trying to make something that you can't afford not to be at. It's almost as like, you know, everyone else is coming. to the board.
And of course, they try and get their money in a couple of different directions. One is from people attending, but the other is from getting companies to sponsor the events. And these conversations always start off brilliantly. You get an email or a phone call from somebody saying, well, I don't know if you're familiar with the Senior Vice President for Exploration from insert name of important oil company here, but he's personally asked me to give you a call and see if you'd be prepared to come along and give a keynote.
Okay.
I'm like, oh, well, that sounds interesting. And, well, let me then send you the prospectus and a range of different commercial sponsorship opportunities that are available to you. And you're like, okay, this is the pattern. I get these calls pretty much every week. And it's very flattering that some senior executive in an oil company who I've never heard of apparently wants me personally there, but it always seems to come attached with a $25,000 to $50,000 bill attached to it. Right.
Yeah. Okay. So anyway, I don't know. I guess I was going to sort of keep an eye on it, and if it fits in with some other things, then maybe show up. It's like you say, the next few years are just going to be fascinating. So it's almost like I want to take every opportunity to see that story unfolding, even if some of them are a bit icky, maybe. But anyway, that's that. The link to the conference is in the show notes if anyone's interested in finding out more about it.
So we've done the Undersampled Radio thing. We're 5 minutes deep, and we've already talked about machine learning and Bashed Conference. So you guys can just switch it off now if you want. Our summary. How about another conference of sorts? Not really. That's going on today. If you're in the New Orleans area, if you're watching this, go over to the Southeastern Geophysical Society meeting in downtown NOLA. I'm not sure what the talk is going to be about because it was a little vague in the details, but you get to eat a nice lunch and talk to people that are interested in subsalt imaging. So that happens at 11:30 at Holiday Inn or something like that. I don't know. It's on the website. The link's in the show notes. Hey, look at this. Another open sourced AI platform. What's that about?
Yeah, I really don't know much about it other than that it's called Paddle, which I just thought was kind of funny.
Awesome.
I don't know if you're paddling upstream or downstream in that scenario. So it's been open sourced by Baidu, which is, huge Chinese search engine, I guess. And I thought that was just kind of interesting, given some of the patterns that Chinese companies have with respect to innovation, not always necessarily coming from within, so to speak. But the reason why I was sort of my ears pricked up a little bit when I heard about it was because their whole philosophy with the platform was to kind of lower the bar to the barrier to entry, so to speak, to get into AI. So they're trying to be as user friendly as possible, and that's really all I know. So I read this in The Verge. You can go check it out. Links in the show notes. It was also the first time in that article that I'd heard about Amazon's platform, DSSTNE, which I'm guessing is pronounced Destiny, maybe, which apparently was open sourced in May. So just sort of add it to the list of everyone open sourcing their machine learning platforms, which is just an interesting trend in itself.
Which one do we start playing with? Which one do we? I'm sure you already know all TensorFlow already.
Well, yeah, that seems to be the one that people are really, really jumping on. And I haven't heard of any other kind of applications of even. I'm sure a lot of .NET people are playing with Microsoft's. I can't remember the acronym, but it's MNST or something. Can't remember. Yeah, and of course, IBM's stuff is fairly accessible through their Bluemix platform. But yeah,
is that Watson?
Yeah.
Did you hear that Wipro bought out a competitor to Watson and decided to call it Holmes?
Hey, there you go.
Nice.
Couldn't make it up. I think that showed a lack of understanding of why IBM chose the name Watson for their machine learning platform. But
yeah, that's right. I can't think of anything unusually witty to say about that, but like you say, you couldn't make it up. I don't know. You move around a lot in this world, David? Are you seeing people picking up these open source packages and applying them to their own problems?
Yeah, and I think one of the challenges is that this stuff's all going to shake itself down in a while. I think, and Graham, you're right. TensorFlow is certainly one that we're doing a lot of work on. I like TensorFlow because I got my 8-year-old to build something out in Jupyter Notebook and start doing character recognition. So I thought the accessibility of it was absolutely brilliant. But there are lots and lots of these different things. And there's a huge amount of overlap, and somehow we're going to have to figure out a way of distilling these things down into a much smaller set of tools, or they're going to have to differentiate themselves. Because at the moment, there's a sense of everybody I go and talk to is picking some particular platform, some particular components. And maybe one day we can chat about. You see parallels with this in the whole platform as a service universe, where the world is starting to break down into people who are going for these platforms where you don't have a lot of choice around what all the different components are. It's all built and assembled for you, versus people who are building their own unique platforms with their own unique sets of components. And I think the challenge is people have got to figure out where exactly they're getting value from these things, and how they're and what they're really in business to do. Because I don't see all of these things as being ultimately sustainable.
Yes, I agree. What are the biggest users, commercial users of, for example, TensorFlow, building out of these platforms? And is there some way to distill the key use points of each platform into a single platform?
Yeah, I mean, I guess my take on how I would expect it to unfold. Well, I don't know. I was going to say that I feel like people will focus more on models, so essentially AIs that already do things, I think, is where the sort of lowest hanging commercial opportunities probably are, rather than in sort of providing access to training and building new models of your own. Does that make sense? So the sort of packaged AI that does a specific thing and has been trained on X data, and then I feel like the natural place to go from that is, how do I continue to train or tweak that model for my own sort of use case? And my reading between the lines, and this might be I might have fallen for the marketing hype here, but I sort of wonder a little bit if that's where Apple and Google are going with these kind of almost ridiculously high-end phones that they're now producing, because they need more compute in the hand of the user to de-generify these AIs, so that your assistant becomes your assistant, and your face recognition things can recognize your face, that kind of thing. So I think that's going to be really interesting. I think the set of people who are actually building new models and even training new models is going to remain fairly small.
Why don't you introduce our guest, since we're already there?
Yeah, right. Okay. Excellent. So David Holmes, who is I think the last I read your title was CTO of Energy.
Yep.
At EMC, now Dell EMC, I think is the official name of the merged.
Yeah, that's right.
The newly merged entity. So the $60 billion largest tech merger in history, I think.
Apparently so.
Went down like a month ago, something like that.
That's right.
And you're based in the UK, I believe, in the southeast of England.
Yeah, my family live in the UK, and occasionally I get to visit them. I have a global role, so this morning I'm in Houston. This afternoon I'll be in Austin, and on Saturday I'll be in Dallas. So.
Yeah. Wow. Okay, you'll be for SEG, I guess, next week.
Yeah.
Right.
Can't wait.
So what does a CTO get up to? That's Chief Technology Officer for the energy vertical.
That's right. And before I say any more, I have to remember that I need to disclose that anything that I say on this podcast is my own opinions and doesn't necessarily represent the opinions of Dell EMC Corporation. Now, the good thing is that the company.
Not a bug, by the way.
Sorry?
That's a feature, not a bug. It's your opinions we want.
Well, honestly, I mean, the good thing about it is the company is pretty relaxed about people turning up on podcasts. So I was talking to somebody in another company who was trying to do a podcast, and they were going through pages and pages of legal madness. And the rough approach within our company is you have to acknowledge who you work for, so people don't think that you're, promoting your company inappropriately, and you have to say, look, this is my opinion, take it as it is, and then roughly we're off the hook. So back to your question, what does the CTO do? I think I have one of the coolest jobs in the industry, but it seems like the job that I'd always been searching for. And essentially, there's three parts to my job. One is I get to look at the entire toolbox of stuff that we have throughout the corporation and figure out which components of it, assembled in which way, make sense for solving problems for energy companies. And that's a pretty fun thing to do. And you can probably imagine my toy box just got a whole lot bigger with the merger. And the reason I'm off to Austin this afternoon is I'm going to see a whole bunch of new exciting toys that we can start using. Second thing I do is we have a dedicated energy research and development center down in Rio de Janeiro. We do a lot of companies working both with service companies, technology companies, but also directly with oil companies, where we're looking to problems that we think the industry is going to be facing over the next few years, and we do applied research projects on how to solve those problems. So kind of things like global collaboration, machine learning, optimizing technical computing, and all sorts of things like that. And then the third part of my job is actually meeting up with oil companies and sitting down and listening to their problems and their troubles and their woes, and then proposing ways of fixing them. So it's a pretty cool job. It suits me.
Yeah. You certainly seem to have fun. Like just from your Twitter, occasionally I see you sort of. I think you tweeted the other day that you were actually programming, and that. I think that's pretty cool if a CTO gets to sit down and dabble in code occasionally.
Honestly, it was one of my big fears about taking this job, is that I essentially turn into a PowerPoint junkie, and my role in the world is to go along and do my 8 slides and then wander off. And honestly, I have been brought into meetings where I'm absolutely meeting the room. I'm brought in, look, you're a terribly important client. I will prove this to you because we brought in our energy CTO, and he's going to sit and smile and not say anything. And then you're going to feel very important. But equally, I've been on a couple of, we have a couple of centers of excellence around the world. So I've ended up sitting in rooms in basements with my laptop and hacking in a way that I haven't been able to for many years. So that's quite fun and unexpected.
And so does your portfolio include any other energy industries, like nuclear, solar? I imagine these people have also got lots of computing needs. Yeah, so
it's a good question. So up until about a year ago, we were the oil and gas vertical, and then somebody decided actually it would make a lot of sense for us to take in the broader energy vertical. So it includes utilities, it includes solar power. Any kind of renewable energy sources, and anything pretty much related to energy. What we're really looking to do, though, is it's not about identifying a bunch of companies and figuring out how to go and sell them hard disks and servers. It's really looking at across the entire market and figuring out how we can construct these things together. I mean, we have something like 30,000 salespeople within the entire Dell Technologies organization, and they're really, really good at selling their stuff and explaining why they have better servers or better storage or better this or better that. And what we're much more about is going and talking to business unit. So I'm a lot less involved with IT departments and energy companies than I am with the kind of the business owners, asset owners. So I get to go and talk to those people about how we can do cool stuff and build stuff and help them solve the problems they want solved.
Are there any cool projects upcoming where you get to utilize these new cool tools you've got with Dell? I mean, anything that sticks out in your mind that you have on the horizon that's going to be an interesting solution?
Yes.
Okay. Thank
well,
you.
And I'm looking forward to coming back and talking to it about it on a future date.
Good.
No, there's what you'll see happening really quickly is EMC had an absolute leading position in the converged infrastructure market. And that's split into two parts, really. Converged platforms, which are really well suited to running conventional client-server applications. And they were essentially a construction of Cisco servers, Cisco networking, EMC storage, and VMware virtualization. And it's fantastically popular. People love it. It's essentially buying a car instead of buying all the components for a car, to use the marketing speak. But then on the other side, you have a new universe of what people are calling hyperconverged infrastructure, where what people are doing is they're saying, actually, I don't want to buy these huge, expensive enterprise systems with high levels of availability. I'm going to let the software be responsible for providing all the availability. And I'm going to use software-defined technologies, software-defined storage, software-defined networking, software-defined virtualization. I'm going to use that to run my infrastructure. I'm going to run this all on commodity hardware. And if you have the right application tool sets, then this can work fantastically well. And it's definitely a direction that the market's moving in. And what I see that's really interesting about that is traditionally we've used companies like Quanta and Foxconn for sort of building those commodity servers for us. But moving forwards, obviously, we're going to use the famous expression, leverage the Dell supply chain. And we'll be building this stuff on our platforms. I'm sorry, using Dell technology servers. And what's really interesting about it is that what I see is over the next couple of years, I think we're going to see a massive centralization of computation. And we're also going to see a move towards what I call composable systems. And what I mean by that is if you think about typical oil companies, they might have seismic processing clusters, they might have reservoir simulation clusters, and they might have interpretation systems. When you distill these things all down, they're basically CPUs, memory, and storage. And it's just different configurations of the same stuff. And generally speaking, in most companies, it's used fantastically and efficiently. We did a survey with a big company in Houston, and their kind of $20,000, $25,000 workstations are running about 7% utilization. And when they added up all of the Xeon processors and the memory and everything else, they went, hang on, this is a supercomputer that's just sitting idle. So what I see is over the next couple of years, we'll see a massive centralization of everything. And we'll see companies start dynamically allocating resources to different workloads. Curiously, I suspect using machine learning technology to automate the execution and allocation of resources. And the thing that I'd keep my eye on as a kind of technology to watch is if you think about the situation today where people have Xeon processors, Xeon Phi co-processors, NVIDIA GPUs for doing computation and visualization. You have a big move back towards FPGAs, real back to the future stuff. Like 20 years ago, we used them a lot. They're really coming back in. I don't know if you saw Intel launched a new CPU on their 14 nanometer process, which integrates both FPGAs and also ARM processing technologies together. And I think this stuff's going to get really, really interesting over the next couple of years. So that's something I'd keep my eye on.
Yeah, it's a fascinating sort of redefinition almost of what software and hardware can do. Like this defining what you normally would think of as hardware resources through software, and on the other side, getting hardware through FPGAs, which I can't remember what that even stands for, but it's sort of a
field programmable gateway. It's a way of basically taking your software and implementing it in hardware, but in a way that doesn't involve you building an $8 billion fab plant.
Right. Yeah. It's sort of flexible silicon is how I sort of think about it, and people starting to sort of implement neural networks in hardware essentially, and sort of almost like building a brain, but it's reprogrammable, so it becomes this sort of software-defined hardware. It's potentially just fascinating.
And it is. It's slightly mad because all of a sudden you're saying, well, hang on a minute. The thing I used to do in hardware, I'm now doing in software, and the thing I used to do in software, I can now do in hardware. And for me, one of the measures of the fact that this stuff's going to kick off is that if you look at Amazon and Microsoft with Azure and Google with GCP, they're all starting to offer up machines that have got these capabilities built into them.
Why hasn't it kicked off already? I mean, FPGAs have been around for a long time.
I think they're really hard. Traditionally, they've been really, really hard to program. Is the simple answer to that, and it's just there are a whole bunch of toolkits. It's becoming easier to do, and the value of them is becoming much more clear as well. So they in a way they never went away, but I think it's going to become a mainstream technology, and people are going to realize that the price performance is something else.
Yeah, it's so funny too. I remember Landmark in like 2003, I think, we're all starting to use these Sun Blades, I think they were called, and they were like these sort of central compute, and you just had a very thin client, and they had these quite neat little smart cards you put in the side of the display, and it would just bring up your session, and you could move to another sort of endpoint and use it there. And I thought that was really awesome. It just went nowhere. I don't know, just disappeared maybe along with sort of Sun. I can't remember. And so it's funny to hear that potentially coming back. I remember we tried to get a project off the ground at Conoco using Boink to exploit all those idle workstations in a sort of grid computing way, like overnight and that kind of thing. That went absolutely nowhere, but it's such an awesome idea, right? I also felt like in Canada, it might take care of some of the sort of heating bill and that kind of thing too. Just having all these workstations burning away at basically 99%, 24 hours a day.
Yeah, that's right. And but again, I mean, you kind of raise a good point, because my very first job in the oil and gas industry was figuring out how to run Paradigm Geolog on Citrix Metaframe. Okay. Which is a really grim and clunky task, but we got it up and running, and it was all part of the company I was working for at the time was trying to build themselves as an ASP business, which one of those long forgotten acronyms. But the idea is that you didn't need a workstation; you could go anywhere you like, connect through a web browser, run this application, and you'd get a good experience. And the truth is that was well ahead of its time, because you couldn't solve 3D, and bandwidth was a problem, visualization was a problem. But in the last 18 months, the industry has completely transformed. The work that NVIDIA has done on solving some of the problems of gaming issues and delivering those have really all of that technology is filtered straight into our vertical, and I'm seeing this is going to be a huge area of adoption over the next couple of years. People are going to... Sorry, go on.
When can I stop buying workstations already?
Sorry, say again?
When can I stop buying workstations already?
Right now.
Okay.
Right now. You can absolutely stop buying workstations right now. This is what I tell pretty much everyone I meet. Is there are a few edge cases where if you want to be on a plane without an internet connection and you have to be running Trell, or pick your geoscience application of choice, but whatever it is, there's some magic that the VDI or thin client computing can't solve. But curiously, the neat solution to this now, which I saw demonstrated recently, is you can essentially grab your virtual machine image from the network, drag it down to your laptop, and walk away with your own personal data center on your laptop. Now, for those edge cases, you're still going to need a workstation class laptop. If you're going to work with big data sets and everything else. But the days of big, tall tower workstations under desks, I think we'll see those disappear over the next few years.
Interesting.
Excellent.
Are you seeing any? One of the other sort of relatively recent, I think it was maybe a year ago now though. Open source releases was Facebook open sourcing its hardware, the sort of GPU blades or whatever you call them, in the Open Compute project, I think it was called.
Yeah.
Are you seeing any interesting hardware open source stuff happening?
No, is the short answer to that. I think I think the Open Compute project, I followed it, it was quite interesting. But essentially, if you look at who's making computers in the world, in reality, it falls down to there's a bunch of ODMs who will white box you a machine to your design and choice. And then you have the major companies like Dell, Lenovo, and HPE who are producing at massive scale. And the real question is that when you think about open source or open technology hardware, you think, well, how much am I saving myself? Because I still need to buy the core components. And in reality, the people who are making hardware are making it at such fantastic scale, they're essentially able to amortize all of their engineering and design costs over a vast number of systems. So the marginal cost saving of buying proprietary versus open systems is not enormous. So it doesn't become compelling, because what a lot of people who are investing in kind of on-premise hardware solutions, they want something really easy. They know it's going to come with a bunch of industry standard components, but what they want on top of that is management, orchestration, service, reliability, and those things, and then probably all wrapped up in some fantastic leasing deal as well. So they become the things by which people differentiate their offerings, but the marginal cost isn't enormous of going down the vendor versus proprietary route.
Right. So it's almost like the open source model works best. It almost only really makes sense for things which are very easily replicated. Or essentially, you replicate them for free, like software, like content, books, photos. And it's less compelling for something that actually has this sort of physical manifestation that you've got to pay for.
Exactly. So even if you had an open source CPU design, you still have to find some way of fabricating it, which is going to have some significant material cost. So I think you're right. I think it's really interesting. I think for the people who run at hyperscale, people who are putting hundreds of thousands or millions of servers, having your own proprietary hardware design is a massive differentiating factor.
Yeah, that was the thrust of, I think, the Open Compute project, was sort of, here's how we manage having a bazillion computers running and not too many people needed to kind of take care of them and swap things in and out.
And curiously, even when you look at those use cases, you see companies like eBay, where they're building these huge, massive scale processing systems. They'll still turn to the larger vendors. So Dell built a data center model for eBay, and what you realize is that the reason that people are looking at custom hardware is because they want to do things like take all the fans out. They want to have integrated design of their HVAC systems and the cooling on the servers. So that's where they want the sort of the proprietary design. It's not that they're bothered as to whether or not there's a badge on the front. They just want to make sure they're getting the optimal compute costs of the infrastructure layer.
Yeah.
Where do we put our money? I want to buy some stock. Who do I buy?
Well, sadly, not Dell, because Dell's now a private company.
Yeah.
But you pays your money, you makes your choice. I don't play the game of being a stock analyst. I was interested to note that Nutanix successfully executed their IPO the other day, and they did very well out of it. So congratulations to them. Nutanix. Up until about a month ago, they were one of our competitors in the hyper-converged space, and now it turns out that we're one of the largest sellers of Nutanix systems. So we're now a partner with them through the merger with Dell. So.
I see. And you guys seem to partner somewhat with Landmark too on some things. I keep seeing. I saw your name pop up the other day in association with, it was on a white paper, Halliburton, Earth, some sort of packaged system for subsurface.
Shall I help you out, or shall I let you keep grasping at the? Okay, so one of the things that we do is we work with all of the major ISVs because one of the things that we've seen over the years is that getting infrastructure for petrotechnical applications right is really, really hard. And we wanted to figure out a way of making it much easier for companies to deploy and manage technology. Because if you look at what a lot of the large vendors are doing, they're actually innovating pretty fast at the moment. They're on a 6-month release cycle. They're introducing new science, new interesting algorithms, workflows, new capabilities. And yet, when you go and talk to energy companies, for them, the kind of like the upgrade process is something that they dread. And so you see a lot of companies who will upgrade every 2 or 3 years. They don't have the agility to manage the upgrade cycle. And that's because, frankly, we've made it pretty hard because, when you look at doing updates, you're looking at potentially, Oracle updates, all kinds of infrastructure components you have to update. That's before you get onto the hardware and software requirements and everything else. So upgrading petrotechnical applications becomes hard. That's frustrating for the vendors because they're working really hard to give their customers cool stuff. And it's frustrating for geoscientists because they want the cool stuff and the IT department are telling them they can't have it for a couple of years. And potentially there's a good competitive advantage from being able to adopt the newest technology as quickly as possible. So the work that we do with the vendors is around building standardized systems with automated update and deployment technology to make it as easy and fast as possible, to make sure people have engineered systems where there's a predictable level of performance and where you lose some of the conventional challenges around troubleshooting issues with applications. We make it really easy for people to update and consume their application stack. So Landmark Earth is an example of a product we jointly engineered with Landmark. It builds on top of our Converged platforms. It uses standard installations for all the Landmark components. What it means is when they have a new release, there's an automated update process, so people can really easily deploy a dev test environment for the new applications, test them out. They can roll over. If it all works fine, that's fast. That's fine. They can easily roll back. So it just massively reduces the cost and complexity of managing the petrotechnical environment. And you'll see other vendors are moving in the same sort of direction. Schlumberger have their Blue Cube initiative, which has similar ambitions.
Right.
Yeah, it's like click here to upgrade to Android 7.0 on my phone there. That's simple, huh? Matt's got a question he wants to ask you before we run out of time. And I see it here. Last question on the list. I can see it in his eyes here. He's itching. He's itching to ask you this.
You picked up on my subtle segue.
I did.
So I think maybe a couple of months ago. So I should mention actually, because we could probably talk to David for a couple more hours. We're not going to. Don't worry. You'll still make it to Austin. Because I should mention that. I mean, we were both at Lamar. We may even have been there at the same time, I think, although I don't think we met at the time. But David has stepped up and sponsored, I think, maybe 3 hackathons now that we've done, at least 2 anyway.
Yeah.
And more than sponsored them, like being a huge kind of champion and supporter and just source of advice and come along to them even. Laptop open, hacking away, chatting to the teams, being a mentor, and that's been amazing. I mean, if there's a list anywhere of all the CTOs of big technology companies that will come along to random hackathons organised by random geophysicists in Nova Scotia, then I think you're probably the only person on it. So I just wanted to give you kudos and say thank you in sort of public for that amazingness. And David also is in on the kind of software underground stuff and takes part in the Slack chat group, which is also really cool. And anyway, something he dropped on there a couple of months ago was about Landmark's Open Earth Community, what should I call it, initiative. But that was kind of all there really was to it, and he had a little bit more info, like, hey, actually there's a bunch of companies partnering around this, and EMC is one of them, and we kind of left it there. kind of looking forward to today, really, and having the chance to ask you some more questions about it. So, how about it?
Sure. So let me give you the mile high view then. The general premise is that there are lots and lots of different platforms that people run applications on. Most software companies have their own platform for running applications. Lots of oil companies develop their own in-house proprietary applications. And managing all of the infrastructure around that is hard and complicated and boring and doesn't actually add any value to anyone. So one of our favorite buzz phrases when we talk about software platforms in Dell EMC is undifferentiated heavy lifting. In other words, it's all that code you have that you really don't care about, but you have to have in place, whether it's a SegWide reader is a classic example, right? How many of those have been written and how many do you actually need? So a good example of, if you take Dave Hale's JTK, for example, that's a great example of a really robust, sound piece of code that anybody can take and consume, that takes away a whole bunch of heavy lifting that if you wrote it yourself, you wouldn't add any value, it wouldn't do anything for you. And so the idea about the Open Earth community is to say, actually, if we had one platform that did all of those undifferentiated things, and if we could get academia and the oil companies and other software companies to run on that platform, then everybody's world would be a better place. Everybody could contribute to the one single platform, and we'd stop investing a bunch of time working on platform technologies, and we could just focus all our attention on the science front. Now, there's a cautionary tale here. I'm pretty sure that both of you guys will be familiar with XKCD. And if you took a moment to Google XKCD 927, that's 927, there's a brilliant one where a bunch of guys are sat in a room and they say, it's ridiculous. We have 14 competing standards for this particular thing. We need one universal standard. 2 years later, there are 15 competing standards.
Yeah.
And so if the Open Earth community is going to be successful, it really has to avoid that creating yet another way of solving the same problems. Now, Landmark's approach to this is to say, okay, we're going to contribute our decision-based platform and the OpenWorks data model into an open community, and we're going to invite everybody to join for free. And so, and they're still trying to figure out how you stop the kind of the Russian hackers joining in or somebody from North Korea. But roughly speaking, the general premise is everybody can join and participate for free and have access to the platform for research and development. And the direction of the platform will be controlled by a community executive, which is built up of representatives from oil companies, from other software companies. And in fact, somebody asked the question of whether or not Schlumberger would be welcome, and the answer from Landmark was absolutely. So this really isn't designed to be a kind of a club just for special people, but there are at least 2, if not 3, competing software vendors who are looking to participate, as well as a bunch of different oil companies. And essentially, the motivation is that it's killing us to either develop, support, implement, or test all of these different platforms. So if we can move on to one common platform, which is not controlled by one particular vendor, where we don't have a situation where one vendor can suddenly say, oh yeah, we're not doing that anymore, sorry, you need to go and redevelop your applications. Where there's a clear kind of mandate or charter, I suppose is the right word for the documentation, as to how it's developed, how people can participate, and how people can consume it. Then potentially the world can be a better place, and we can focus more of our efforts on developing software that actually does interesting stuff. Mm-hmm. And for me, what's really interesting about this is that we're at the nexus of companies looking really, really hard at their technical portfolios. And for me, I see every oil company looking at their portfolios from 3 different directions, from saying, okay, some technology, I want to buy proprietary software, it has a clear value proposition, it's great. Some technology, I want to be open source, I'm really comfortable with open source now. 10 years ago, it was banned from my organization, but now I'm embracing it. So it used to be, if you go back 5 years, I would embrace enterprise class open source technology for providing infrastructure, Linux operating systems, databases, things like that. But now actually I'm seeing increasing use of open source technology within petrotechnical workflows. And there are reasons that companies will support and embrace that. And then at the same time, companies are revisiting the question of buy versus build. So for a long time, companies have said, look, we tried writing our own software. It's really expensive. We didn't get very far. We're just going to buy everything in from vendors. And what you realize is, of course, is that doesn't give you a great road for differentiation. Mm-hmm. And what I see now is that companies are coming back. They're revisiting the assumption the buy versus build is the right idea. And they're saying, well, actually, we have particular areas of intellectual property which we want to instantiate in our own code that we want to own that's going to differentiate us as an oil company. So when we're bidding for a license, we're going to have some better technology to apply to exploring and reducing hydrocarbons. And so what I see is we're going to see increasing amounts of development happening inside oil companies. But they're going to be really focused on making sure that anybody who's writing lines of code in an oil company is writing value-added, differentiated IP, and they're not writing Segway readers or seismic visualization tools or anything like that. So the ambition for the OEC is to become a common industry platform with a broad amount of support base that's freely accessible to anyone who wants to participate in the development of it.
Mm-hmm. How and when do we participate?
So the status today is that the founding charter agreements are currently being reviewed by, there's I want to say sort of 14 to 16 founding members that are a combination of oil companies, ISVs and others, and they're going through the legal process of setting this all up and determining how this is all going to work. There's a lot of work been done on the things like the web portals, the development environments and things like that. But there's some legal work that has to be done to get this all set up and working in the way that it needs to. Now, what really astonished me, I was on a 2-hour call last week with all of the participants to review kind of legal feedback on this 10, 12-page document, and I was expecting it to be a bit of a bun fight. Because everybody has their own interests, right? Right. The oil companies come in from one view, competing software companies have a different view. What really astonished me is how everybody on the call was collaborating to try and find a way of getting to a good outcome, which I think bodes well. And nobody should underestimate that this is going to be a challenging thing to make successful. It's not going to be really easy. But in my view, the size of the prize is quite big. Is if we can get to a point where there's a single industry platform that's freely available, and I'm not naive, right? I mean, there are lots of companies for whom this is probably going to be unattractive. There are some people who are going to see it as a sort of an IP land grab. And people for whom they'll go, do you know what, it's interesting, but it's not for me, or I'm concerned about using a platform that has one vendor's has had a strong control of the direction of. But even if in a year's time we've gone from 14 to 13 different platforms, that to me would seem like a bit of a result. And going back to the XKCD thing to wrap up, the one thing I'd say is that at least we're looking at the existing kind of 14 and saying, well, let's try and take one of them, put it into an open community project and make it more broadly available than saying, no, we need to develop a whole new different one.
Yeah, right. Yeah, I agree that feels like a much more likely to succeed than, because you can look at things like OpenSpirit, which kind of had that let's get all these things talking to each other by building another thing, and I mean that's not really worked out.
Yeah, and there's and Open Spirit had a couple of different challenges. One is it was set up to be a commercial entity, and of course, as soon as you introduce kind of, you know, the idea of, you know, money and profits, then you have a whole bunch of different people who have an interest in it.
Yeah, of course.
And of course, you know, Open Spirit set out to solve a really hard problem of how to get everything to talk to everything. And it, you know, it was built out at a time on a set of technologies and platforms that, you know, there are use cases for Open Spirit that have been well proven and used, and lots of companies use it to solve specific problems. But it didn't work out to be the global panacea to all data exchange challenges that were ever conceived.
And so you alluded to some of the potential restrictions, like access for R&D, which I assume means something like non-commercial use. And so are we talking about access to SDKs, like software development kits here, or are we talking about open source code? What do you know what Landmark is really bringing into the picture?
So the crux question, the really tricky one, is is Landmark putting all of this code on GitHub and making it freely and openly available?
There you go.
And the answer to that, I'll phrase the question in the way where you might have done that makes it difficult. So the answer to that question is not now. So whilst and you know, I'm speaking on behalf of Landmark. So whilst what I'm offering is my opinions, you know, Landmark have every right to go, no, he completely misunderstood. This is my understanding of their position.
I get that.
But essentially, my understanding is that whilst in principle, Landmark are not averse at some point in the future to going down the open source route, they're concerned that it's not the right thing to do right now, and they want to they want the community to maintain some control as to how the platform's developed. They want to avoid things like, you know, code forks and, you know, somebody running off Monty Python style saying, no, this is the true open earth community. No, I have the holy gourd of the open earth community. And so that's a concern, and they want to certainly initially maintain a bit of discipline around how the platform was developed and maintain it within one community. Now, in terms of access to the platform, it will be you'll have access to a development environment, which, as I understand it, will give you full access to the source code of the community platform, and there'll be a clear process for how development projects are proposed, how they're reviewed by the executive committee, and how they're then executed, and how there's agreement around specifications, around testing, and all these things. So there's actually a huge amount of work that's gone into thinking about how realistically this might operate, and it really does take into account if I was a software vendor, how would I participate? If I was an oil company, how would I participate? If I was an academic and I've got this fantastic new algorithm, how would I go about implementing that and using that? Yeah. So there's more detail to come out, but the basic premise is exactly that. And in terms of the availability of how you'll use it in commercial kind of productive use, it's still likely that there'll be some charges for using the platform. So think of it a bit like kind of Red Hat.
Yeah,
it'll work on a model a bit like that. Or something like Pivotal Cloud Foundry, where, you know, open technology, but here's the commercial release with support and warranties and maintenance and all those good things as well. Yeah, and I think my view is I think this might evolve over time. I think there are some questions around how individual contributors might work with the platform, how academics might work with it, and there's an enthusiasm to kind of definitely have those things on the radar. But in the short term, I think the real focus is on getting the whole thing up and running, getting people access to the code, and having people start driving adoption of the platform.
Yeah, right. Well, it's a fascinating move. And I know most of the people on Software Underground and many subsurface scientists, especially ones who code, will be watching it with interest to see how it unfolds. So thanks for giving us such a informed and succinct and eloquent summary of what's going on there. Because I think it's for me, the industry needs to have some epiphanies, right? And it sounds like this is the beginning of one of the epiphanies that I think it needs to have if it wants to get innovation and invention up to the kind of levels that we're going to need to see to
I think you're right. And you were at the EAG open source workshop, and so you saw that situation where we had presentation after presentation of people who'd roughly written the same kind of thing, right. Where there's an enormous amount of duplication, and the collaboration between all of those initiatives seemed to be not strong.
Yeah.
And I think anything that we can do to make sure that the really super smart scientists we've got sitting in academia hacking away, we want them to do things that are unique, different, and are contributing to the greater good, rather than just, oh boy, we're going to write another one of these.
Yeah, right. Totally.
Hope for the future. David Holmes, thanks for coming on the show today. We really enjoyed your insights and just having a little chat with you.
It's been great fun. Happy to come back anytime.
Awesome.
All right, guys. We will see you next week with episode 24 of Undersampled Radio. Bye-bye.
Bye.